Let's take a look at motion and vectors. So Chapter 2 deals with two-dimensional motion. One-dimensional motion, you'd be moving along in a straight line, either forward or backward, left or right. Two-dimensional motion, we can go left, right, as well as up, down. Therefore, we need to use vectors when we're talking about this stuff. So we're going to talk about vectors and introduce some terms so that everybody knows what we're talking about. First term we're going to look at is scalar. Definition of a scalar is a quantity that has a magnitude but not a direction. This is a word you're going to see a lot. You need to know its definition. Magnitude means size or quantity. Examples of scalars, let's see if you can think of any first of all. Examples we can provide of scalars would be time, length, mass, volume, and my guess is you can come up with a variety of other quantities where you know how much, but which way it is pointed or headed is either not a factor or not important. A vector is a quantity that has both magnitude and direction. So when you're talking about how big something is, you also have to talk about which way it's traveling. So let's see if you can think about some ideas of quantities that might be vectors. Vectors that we will be working with are displacement, similar to but not the same as distance, velocity, force. These are all quantities that we will be dealing with. They are vectors, so when you're talking about them, you need to include their direction. And the way we signify direction is with a plus or a minus. The plus can mean up, the plus can mean left, the plus can be right. You choose the direction and you choose the sign. What that means is if you have something traveling left and then traveling right, one of those directions needs a plus sign, the other direction needs a minus sign. So when you do the math involving vectors, you get the correct answer. So if I want to do some math involving scalars, that's just ordinary arithmetic. So if I want to take 5 meters plus 6 meters, I get 11 meters. I don't know if that 11 meters is up or down or left or right. All I know is how far it is from start to finish. When I add vectors, I have to add them graphically. Generally that means drawing a diagram because I have to take into account the direction. And when I add it with directions, I need generally to use arrows. If I take a look at an example where I have 5 kilometers to the east that is traveled first, then I travel 6 kilometers to the west. What I want to know is displacement. And the definition for displacement is change in position. Change in position is where did I start, where did I end, what is the distance between those 2 points. So if I start here and we'll go this way to go east, so here's 5 kilometers east, and then I turn around from this point and I head west, and I head west 6 kilometers. So I started here, I ended here. What I'm interested in is, from here to here, is my displacement or my change in position. So the math I'm going to do is 5 kilometers, I'm going to make east positive. And then I'm going to add my vectors because when I add them, they're head to tail. And going to the left is going to be negative 6 kilometers because heading to the right or east was positive. So positive 5 plus minus 6 is negative 1 kilometer. So my change in position, my displacement is negative 1 kilometer. This negative sign tells me I'm headed to the left. So signs tell us direction when we're doing the math. So that's a fairly easy vector addition problem. It's one-dimensional. I'm going along the x-axis, left, right, if you want to think of it that way. Now what happens when we have 2 dimensions? So in this particular problem, I'm going 5 kilometers east and then 6 kilometers north. So how do I figure that out? So the first thing I'm going to do is sketch out the vectors. So here I have 5 kilometers east. I started right here and I head east 5 kilometers. And then when I get to the end of that trip, I'm going to turn north and go north 6 kilometers. So there's my starting point right here. Here's my ending point right here. So I start here and go to here. That green line then shows my displacement. That is called the resultant. So the resultant is a vector sum. So if I'm trying to determine the magnitude of the resultant, well, I have a right triangle. So if I remember how to find the hypotenuse of a right triangle, I'm in good shape. And I do, so I'm going to take 6 squared plus 5 squared, and that's going to equal the square of my resultant. So I do the algebra, and I will get a resultant of 7.8 kilometers. So that is the length of this vector. That is my resultant from starting point to ending point. To find the direction, essentially what I'm doing is I'm finding the angle. So the angle I want to find is this angle right here. So trigonometry comes to my aid. To find that angle, I want to find a tangent of it, because the tangent of it is the opposite side, which is 6 kilometers, over the adjacent, which is 5 kilometers. So I find the value, take the inverse of that, and I find an angle of 50.2 degrees. So that is the direction, and I can't just leave it as an angle because 50.2 degrees could be anywhere. So in terms of my compass points, it's 50.2 degrees north of east. So my magnitude for my resultant vector is 7.8 kilometers. The direction it points is 50.2 degrees north of east. So that's how I can take vectors, multiple vectors that are at right angles to each other, and find a single resultant or vector sum. Sometimes when I'm adding vectors, they are not 90 degrees to each other, and when that's the case, I have to break them into their components.